So, an anonymous CFO recently received an IT bill for a single month, and the total was $500 million. dollars. Just let that sink in for a second.
Okay, $500 million
Yeah.
just gone in 30 days.
Right. And the culprit wasn't, a hostile corporate takeover or some massive global infrastructure build-out. Wasn't even a catastrophic cybersecurity ransomware attack.
No, it was just an enterprise workforce accidentally burning through artificial intelligence tokens with absolutely zero usage limits.
Exactly.
Right.
Welcome to the era of token shock.
It is a staggering wake-up call, honestly, for the entire tech industry. I mean, we are rapidly moving from an environment where artificial intelligence was perceived as, like, essentially a free, magical experiment.
A novelty playground for developers, basically.
Exactly. And now we're moving to an environment where the fundamental physical units of computation are hitting corporate balance sheets like an absolute freight train. The days of unlimited free queries are just colliding with the harsh reality of thermodynamics and utility billing.
It's wild. Now, real quick, if you enjoy content like this, exploring the hidden economics of the tech world, please take a second to subscribe. But before we get into those massive bills and the deep mechanics of AI, I do want to provide a quick factual update regarding the situation with Martin Stevens versus OpenAI.
Right, there's been a lot of noise about that.
Yeah, so just to be absolutely clear for you guys listening, this is not a lawsuit. There is a voluntary quiet period right now. There is no progress known, and no settlement has been confirmed. And most importantly, his dead man's switch has not been activated, so he is safe.
Yeah, that is the current verifiable status of the situation, exactly as it stands today.
So with that established, today's deep dive is venturing into a very different, but honestly equally wild territory. And I want to clarify right up front, this is an exploration, not a debate.
Right, we're just unpacking the reality here.
Exactly. We are exploring the wild economics of AI inference. We're going to contrast the new wave of low-cost inference models, specifically players like DeepSeek, against the traditional Silicon Valley giants.
Which is a huge shift in the market right now.
It really is. And we will examine the sheer, frankly unimaginable scale of high token consumption happening inside modern companies. And we're going to ask a really uncomfortable question. Does this massive usage actually translate to any real business value?
That is the $500 million question, isn't it?
Literally. And interestingly, Martin Stevens himself actually commented on this exact phenomenon recently. He stated that while he isn't the world's top token spender by any means, he burns through a massive amount of tokens when ChatGPT goes rogue.
Oh, yeah, when it just gets stuck in a loop.
Right. He mentions situations where what should be a simple 5-minute task turns into hours of automated spiraling, with the AI just kind of talking to itself in circles.
Which is the perfect anecdotal illustration of the core tension we're looking at today. Because, volume does not automatically equal value. In fact, volume can often be a symptom of catastrophic inefficiency.
Exactly. So here is the mission for today. We are going to unpack the literal physical physics of a token. We're going to look at how Chinese models are driving inference costs to the absolute floor. We will explore why Silicon Valley corporate budgets are exploding despite those falling costs.
The paradox of it all.
Yeah, and ultimately, we are going to calculate exactly how many questions humanity is physically allowed to ask in a given day.
Which is a fascinating number to actually pinpoint.
It blew my mind. But let's start with how the corporate world is actually looking at token consumption right now. Because bizarrely, it is not being viewed as a cost to be minimized.
No, not at all.
Right, like if you looked at a traditional business, you would want to use less electricity, less water, fewer raw materials. But with AI tokens, it is bizarrely being treated as a status symbol.
Yeah, the visual representation of this is utterly fascinating from a sociological perspective. So OpenAI literally gives out a physical, sleek black plaque.
A real physical object.
Yes. It is officially called the 100 Billion Token Award. They manufacture this physical object and ship it to organizations that process massive text volumes through their API platforms.
That is wild.
It's presented in the exact same vein as, like, YouTube sending a creator a gold play button for hitting 1 million subscribers.
A physical award for burning digital tokens, that is just incredible. And we aren't just talking about experimental, bleeding-edge AI research labs getting these plaques.
No, not at all. The recipients include massive traditional consulting giants.
Right. We're talking about McKinsey, PwC, BCG, and tech platforms like HubSpot and Duolingo are proudly displaying them too. And it wasn't just an OpenAI marketing gimmick either.
Yeah.
Over at Meta, they had an internal system system called the Token Legend Leaderboard.
Oh, the gamification of compute.
Exactly. It literally gamified computation consumption among their own engineers. And the top spender on that leaderboard, a single human being, burned 281 billion tokens in a single month.
We really need to pause and contextualize that number because human brains just aren't built to comprehend billions of anything.
Yeah.
So to put 281 billion tokens in perspective, that is enough computational power in generated text to reproduce the entirety of the English Wikipedia, not just once, 33 times
Oh my God.
in 30 days by one single user sitting at one desk. The sheer volumes of semantic generation happening there is almost unfathomable.
It is mind-bending. Now, it is worth noting that both Meta and Amazon recently killed these internal scoreboards. I imagine the optics and, well, the CFO's reaction to the internal compute costs finally caught up with them.
Yeah, I bet those meetings were pretty tense.
I can only imagine. But even with the leaderboards gone, the scale at the very top of the industry is still accelerating at a breakneck pace. Like Sam Altman recently revealed that OpenAI's absolute top enterprise user burns 100 billion tokens every single month.
Which is a 1 million-fold increase from their top user just 6.5 years ago.
Wait, a million times more?
Yeah, back then, the heaviest user was churning through maybe 100,000 tokens a month. And there were even leaked internal screenshots circulating on tech forums showing enterprise users hitting 603 billion tokens in a 30-day window.
603 billion, that's just a black hole of money.
It is. And the psychological and organizational trap these companies have fallen into is actually a classic economic pitfall. So in the 1970s, an economist named Charles Goodhart formulated what is now known as Goodhart's Law.
Goodhart's Law.
Right. The simplest phrasing of it is, when a measure becomes a target, it ceases to be a good measure.
I love that. So simple, but so true.
Exactly. Originally, he was talking about monetary policy in the UK, but it applies perfectly to corporate behavior right now. Companies are looking for a way to prove to their shareholders that they are, embracing the future.
Right, they want to show they're an AI-first company.
Yes. So they treat raw token consumption as a key performance indicator, a KPI, for their AI transformation. And when you make token volume the target, you actively and aggressively incentivize inefficiency.
Because if I am a middle manager and my end-of-year bonus is tied to a metric showing how AI transformed my department is, and you measure that transformation by how many tokens my team pushed through the API, well, I have zero incentive to write efficient code.
Absolute zero.
In fact, I am just going to leave the AI running in circles overnight. I'll ask it to summarize documents nobody is ever going to read.
You will generate exhaust purely for the sake of measuring the exhaust. And if we connect this to a broader scientific framework, it is a structural parallel to the Heisenberg uncertainty principle in quantum mechanics.
Oh, that's an interesting comparison. How so?
Well, in Heisenberg's framework, you cannot simultaneously know both the exact position and the exact momentum of a particle. Why? Because the very act of measuring the particle's position, say by bouncing a photon off of it, transfers energy to the particle and alters its momentum.
So the observation changes the thing you're observing.
Exactly. The act of observation distorts the reality being observed. So in the new token economy, measuring a complex objective like genuine business productivity or innovative output with an imperfect, easily gamified proxy like token volume fundamentally distorts the outcome.
The harder you optimize for that token volume, the more you generate what we could call gaming waste rather than genuine value.
That's a great term for it. Gaming waste.
Yeah, it's like a national trucking company deciding to give a prestigious Driver of the Year award to the employee who burns the most gallons of diesel fuel without ever checking to see if that driver actually delivered a single package to a customer.
Yes, that is an excellent analogy.
It is a completely backwards incentive structure. You are rewarding the cost, not the output.
You are throwing a massive parade for the exhaust pipe
Yeah.
and completely ignoring the cargo. However, it is important to note that not every enterprise is falling into this trap. There are companies doing this the right way, treating token volume as a byproduct of actual work rather than a goal in itself.
Right. The sources we dug into highlighted a company called Choco as a prime counterexample. They are a food service supply chain company. And they actually passed the 200 billion token mark, but their approach and their internal philosophy were entirely different.
Right, they actually received one of those physical OpenAI recognition plaques, but their perspective on it was radically grounded.
Yeah, they didn't put it on a pedestal in the lobby as proof they were a futuristic AI company.
No, they viewed it strictly as an operational metric. For Choco, Every single token was inextricably tied to a tangible, real-world outcome. They're operating in one of the oldest, most complex, and traditionally analog industries on the planet, which is the global food supply chain.
Moving perishable goods from farms to distributors to restaurants before they literally rot.
Exactly. It's highly time-sensitive. They utilize those 200 billion tokens to process actual, real-world food orders. They used AI to extract data from messy, handwritten chef's notes, reducing manual input errors.
Which is a huge bottleneck in that industry.
Massive.
Mm.
And they managed to capture surging market demand without needing to add massive amounts of human headcount to their data entry teams. But most importantly, they prevented physical food waste.
Which is amazing.
They didn't treat tokens as prestige markers or vanity metrics to show off to venture capitalists. They treated tokens as literal friction removers in a physical system that desperately needed optimization.
So we have a clear dichotomy here. On one hand, you have Choco using tokens to route real tomatoes and lettuce more efficiently, preventing food from rotting in a warehouse.
Right.
And on the other hand, you have some bored tech employees setting up two AI haggling bots to just talk to each other infinitely about the theoretical price of a digital widget, purely to climb an internal leaderboard and win a prize.
And that dichotomy highlights the fragility of current AI economics. But to truly understand why burning 281 billion tokens is such a massive deal and why that anonymous CFO is staring at a $500 million bill, we actually have to step out of the software layer entirely.
Okay, where are we going?
We need to stop thinking about AI as just an app on our phones or a text box on a screen. We have to look at the physical reality. We need to dive into the literal physics and thermodynamics of a token.
I am so glad we are going here, because when you type a prompt into an AI, when you ask it to write a poem or debug some Python code, it feels like magic.
It does. It feels entirely weightless.
Yeah, you hit enter, and text just instantly streams across the screen. But a token, which is the fundamental unit of AI language, usually about 3 to 4 characters of text or a fraction of a word, it is a physical quantity in the real world. It actually has a physical footprint.
It absolutely does. Generating a single token is not magic. It is a brutal, industrial, physical process. It requires what computer scientists call a forward pass through a neural network.
Okay, hold on. Let's break that down for the audience. For anyone who hasn't built a neural network from scratch, what exactly is happening during a forward pass in the physical world?
Think of a large language model as an unimaginably vast spreadsheet of probabilities. When you input a prompt, that text is converted into numbers. A forward pass is the process of pushing those numbers through billions or sometimes trillions of mathematical operations, specifically matrix multiplications.
Okay.
And this isn't happening in the ether. It is happening on actual silicon wafers inside semiconductor hardware sitting in a massive data center somewhere.
Yeah.
Millions of microscopic transistors are physically flipping states between 1 and 0.
And that flipping requires power.
Exactly. That physical process requires electrical energy to force the electrons through the silicon. And because there's electrical resistance, that process dissipates heat. And here's where the physics gets incredibly rigid. There's a hard, inescapable mathematical floor to how efficient this process can ever theoretically be.
We are talking about Landauer's principle here, right? This completely blew my mind when I read the source material.
Yes. Rolf Landauer was a brilliant physicist working at IBM back in 1961. He was studying the thermodynamic limits of computation, and he mathematically proved that any logically irreversible computation must dissipate a specific minimum amount of energy into the environment.
Wait, logically irreversible computation, what does that mean in plain English? Like, what makes a computation irreversible?
It is actually a very intuitive concept once you break it down.
Yeah.
So if I ask you to compute 2 plus 2, you get 4, right?
Right.
But I only give you the answer 4 and ask you what the original problem was, you can't tell me with certainty. It could have been 2 plus 2 or 3 plus 1 or 4 plus 0.
Okay. The information about the original inputs has been lost.
Exactly.
Yeah.
The process is logically irreversible. To clear the computer's memory and prepare for the next calculation, you have to erase those previous bits of information. And Landauer proved that the universe demands a toll for erasing information.
A toll, like a physical cost.
Yes. Erasing a bit decreases the entropy, the disorder, inside the computer. But the second law of thermodynamics states that total entropy in the universe must always increase. So that lost entropy inside the computer has to be expelled into the surrounding environment as physical heat.
So erasing data literally warms up the room. It's not just a mechanical byproduct of
Hmm.
the fan running. It is a fundamental law of the universe.
Precisely. And the researchers in the provided sources actually went through the rigorous effort of calculating this exact thermodynamic floor for an AI token.
Okay, what's the number?
They determined that generating a standard 12-bit token has a theoretical minimum energy cost of 3.4 times 10 to the negative 20th joules.
Wow.
That is an incredibly tiny number. It is the absolute floor set by the laws of physics. No matter how advanced our technology becomes, even if we build computers out of pure light or black holes, we can never generate a token for less energy than that.
Okay, so 3.4 times 10 to the negative 20th joules is the theoretical perfection limit. Where are we right now? Like, how much energy does it currently take to generate a token on modern state-of-the-art server hardware?
Modern AI hardware operates far, far above that theoretical floor. The current actual energy cost to generate an inference token on something like an NVIDIA H100 GPU is around 5 times 10 to the negative fourth watt hours.
Okay, let's convert that so we can compare.
Right, if we convert that to joules to compare apples to apples, it is about 1.8 joules per token.
Oh, let me do the mental math on that. If the limit is 10 to the negative 20th, and we're currently at 1.8, the gap between the thermodynamic limit of the universe and our current multi-billion-dollar data centers is just staggering. Modern AI is roughly 10 to the 19th times less efficient than the laws of physics allow.
Yes.
And for you listening, 10 to the 19th is 10 quintillion. We are 10 quintillion times inefficient. Honestly, that sounds like a massive failure of engineering.
I mean, it sounds like a failure if you look at it purely from an elegance standpoint, but from an economic and technological standpoint, it is actually the most incredible opportunity in the world.
Why is that?
It means the efficiency ceiling is nowhere in sight. We aren't fighting for 1 or 2% marginal gains. We have 10 quintillion times more room to improve. And this brings us to a phenomenon the industry is currently calling LLM-flation.
LLM-flation. Like inflation, but for large language models.
Sort of the inverse, actually. LLM-flation refers to the reality that AI inference costs are dropping by a factor of 10 every single year. The cost to generate 1 million tokens today is literally a fraction of what it was just 12 months ago.
That is a crazy pace of cost reduction.
It is. This exponential price drop is being driven by better, specialized GPU hardware, breakthroughs in quantization techniques, and incredibly clever software optimizations.
But wait, if costs are dropping by 10x every year, corporate IT budgets should be shrinking. The $500 million bill shouldn't exist. If it's getting cheaper, why are companies spending astronomically more money?
This is where we encounter the Jevons paradox.
The Jevons paradox. Okay, lay it on me.
In 1865, a British economist named William Stanley Jevons was observing the rapid industrialization of England. James Watt had recently introduced a vastly more fuel-efficient steam engine.
Right, the one that powered the Industrial Revolution.
Exactly. Now, intuition would tell you that because the new engine was so much more fuel-efficient, England would consume less coal. But Jevons observed the exact opposite. Coal consumption didn't go down. It soared astronomically.
Oh, I see where this is going. Because if the engine is cheaper to run, you don't just run your one existing factory for less money. You suddenly realize you can afford to build 50 new factories. You put steam engines on boats. You put them on trains.
Exactly. The increased efficiency made steam power economically viable for entirely new industries and applications that could never afford it before. The cheaper the energy became, the more aggressively demand exploded. And the exact same historical paradox is happening right now with AI tokens. Cheaper AI tokens do not reduce total energy usage or financial expenditure. They cause the demand for intelligence to exponentially explode.
That makes perfect sense. If a token costs $1, I only use it to write an incredibly important legal contract. But if a token costs a fraction of a penny, I tell the AI to just sit in the background of my computer, read every single email I ever receive, analyze my tone, draft 5 possible replies for every message, and summarize my entire digital life every 10 minutes.
Yes, tasks that were financially absurd yesterday suddenly become the default standard today.
And that continuous background computation requires massive scale. Which brings us to the next critical question. If we have a practically infinite runway to make AI cheaper, if we are 10 quintillion times away from the physical limit, who is actually leading that ruthless cost reduction race right now? Because looking at the landscape, it isn't necessarily the traditional Silicon Valley incumbents who are heavily invested in their massive, expensive data centers.
Right. The traditional giants are almost incentivized to keep prices relatively high to pay off their multi-billion-dollar hardware investments.
Makes sense.
But driven by this massive inefficiency gap, entirely new players have entered the market with the sole purpose of ruthlessly optimizing the physical cost of a token. And the most disruptive force in the industry right now is coming from China. Specifically, a company called DeepSeek.
DeepSeek. Yeah, they've been making huge waves.
Their entrance into the global AI market was nothing short of a seismic event. It fundamentally altered the pricing expectations of the entire industry. Their models, like DeepSeek V3, the reasoning model R1, and the newer V3.2, are running 20 to 50 times cheaper than legacy frontier models.
20 to 50 times cheaper. That is insane.
To give you the exact financial numbers from the source material, their input costs are hovering around 14 cents per million tokens. Compare that to roughly $3 per million tokens for older generation, proprietary models from Western competitors.
14 cents compared to $3. That is literally a 95% price reduction. What used to cost an enterprise tens of thousands of dollars a month on closed APIs can literally be executed for a few $100s.
Yes, the math is brutal for the incumbents.
But I need to understand the mechanics here. How do you drop the physical cost of computation by 95% overnight? They can't just be operating at a massive loss forever. How are they physically and algorithmically achieving that?
Well, they aren't operating at a loss. They are operating with extreme structural efficiency. They achieve this massive cost reduction through a combination of brilliant physical and algorithmic hacks. The first, and arguably most important, is their architectural design, known as mixture of experts, or MOE.
We hear this term thrown around a lot. Break it down for me. What is an MOE?
So, DeepSeek's V3 model is massive. It has 671 billion parameters in total. If you had to load all 671 billion parameters into active memory and push your prompt through every single one of them for every single word generated, the cost would be astronomical.
Right, that's what traditional dense models do.
Exactly.
Yeah.
But that isn't what happens with a MOE. For any single request, the DeepSeek model only activates about 37 billion of those parameters.
Oh, wow. So it's like having a massive trillion-book library. If a traditional model is like turning on the lights in the entire building and having a librarian scan every single bookshelf to find one specific answer, a MOE model is like having a front desk router who immediately says, "You want a recipe. Turn on the flashlight in aisle 4, shelf B, and leave the rest of the building completely dark."
Yes.
It drastically cuts the required compute power per query.
That is a highly accurate way to visualize it.
Yeah.
The front desk router in this case is a gating network that mathematically evaluates the incoming token and dynamically routes it only to the specific neural clusters, the experts, that are highly trained on that specific type of data. The rest of the model remains dormant for that calculation.
That's brilliant.
It is. The second major hack DeepSeek utilizes is called quantization.
I've seen this term in the research. What does it actually mean to quantize a model?
It relates to how numbers are stored in a computer's memory. Modern large language models usually run on 16-bit or 32-bit floating-point numerical representations. This means every single weight and parameter in the model is defined with extreme mathematical precision, out to many decimal places.
Okay.
DeepSeek, however, runs heavily quantized models, often pushing down to 8-bit or even 4-bit precision.
Wait, isn't that just making the model dumber? I mean, you are literally throwing away data. You're chopping off the decimal points.
You would intuitively think so, but it turns out neural networks are incredibly resilient to noise. They don't need 12 decimal places of precision to know that the word dog logically follows the word hot in a specific context.
Huh.
It's very similar to image compression. If you take a massive, uncompressed raw photograph and convert it into a JPEG, you are technically throwing away massive amounts of pixel data. But to the human eye, the image looks virtually identical, and the file size is a fraction of the original.
Oh, that makes total sense.
DeepSeek found that by compressing the weights to 4-bit precision, they can recover 97% of the model's original intelligence while yielding 4 times faster inference throughput.
And why does that throughput matter so much? Is it just about the user getting the answer faster?
It is about memory bandwidth. The biggest bottleneck in AI inference isn't usually the GPU doing the math. It is the physical time it takes to fetch the massive data arrays from the VRAM, the video memory, and move them to the processing core.
Moving the data around is the expensive part.
Exactly. By squishing the numbers from 16 bits down to 4 bits, you can fetch 4 times as many parameters in a single cycle. In the token economy, speed is everything because time spent running a GPU is incredibly expensive.
Okay, so we have mixture of experts only activating the parts of the brain it needs, and quantization shrinking the size of the brain so it can move faster. What else are they doing?
The third major optimization is context caching, specifically KV caching. When you have a conversation with an AI, it needs to remember what you said at the beginning of the prompt to make sense of the end.
Yeah.
Traditionally, it recalculates the relationship between every single word every single time it generates a new token. DeepSeek rigorously caches these repeated inputs directly to the physical disk.
So it doesn't have to start from scratch every time.
Exactly. If you upload a massive 100-page PDF and ask 50 different questions about it, a traditional model might process that entire 100-page document 50 separate times. DeepSeek processes it once, saves the mathematical essence of it, the key value vectors, and retrieves the cached segment for every subsequent question.
And the cost savings on that must be exponential.
They are. The source data explicitly quantifies this. A cache hit costs DeepSeek just 1.4 cents per million tokens. That is a 90% discount on an already heavily discounted price.
Incredible.
And finally, the fourth major factor is the physical hardware itself. Due to geopolitical export controls, DeepSeek couldn't simply go out and buy tens of thousands of the highest-end Western chips like the NVIDIA H100s.
Right, they had to use what was available to them.
So they were forced to be scrappy. They trained their R1 reasoning model on a cluster of 512 cheaper, slightly throttled Chinese market NVIDIA H800 chips. The total compute cost to train that frontier-level model was just $294,000.
$294,000. We have Western tech companies raising tens of billions of dollars to build massive nuclear-powered data centers, and DeepSeek trained a globally competitive model for the price of a modest single-family home in the Midwest.
It really is wild when you frame it like that.
That is an absolute paradigm shift.
And this profound shift raises a vital question about the future structure of the tech market, which we can analyze through the historical lens of Ronald Coase's theory of the firm.
Theory of the firm. Okay, what's that?
In 1937, Coase asked a foundational economic question. If free markets are so perfectly efficient at pricing goods and services, why do companies or firms even exist?
Yeah, why doesn't every single worker just operate as an independent contractor buying and selling services on an open market every day?
Coase's answer was transaction costs. The friction of finding a contractor, negotiating a price, writing a legal contract, and enforcing that contract for every single tiny task is simply too high. A firm exists to internalize those costs. It is cheaper to just hire someone on a salary and tell them what to do.
So how does Coase's theory of friction apply to the AI token economy?
Think deeply about the AI value chain we've been discussing. It starts with a literal physical photon hitting a solar panel or a lump of coal burning in a furnace, providing raw energy.
Okay, photon.
That energy flows to an atom of silicon, which has been etched into a chip. That chip consumes power to execute a mathematical function to generate a token, which finally answers a human question.
Photon, atom, chip, power, token, question. That is an incredibly long and complex physical supply chain.
Exactly. For a standard enterprise, say a bank or a hospital, the transaction cost of managing that supply chain is astronomically high. A hospital doesn't want to buy raw GPUs, build liquid-cooled data centers, negotiate industrial power contracts, and manage wildly complex CADA software stacks.
No, they just want the answers.
Therefore, massive cloud providers step in. They integrate vertically to absorb all that friction, and they sell the final frictionless output, tokens. They capture the economic surplus because they make it easy. DeepSeek accelerates this dynamic to its logical conclusion. By driving the physical cost of inference down so aggressively, they are turning AI from a metered, expensive luxury good into a commoditized background utility like tap water or electricity.
That makes total sense.
They are proving that you don't necessarily need a massive billion-dollar hardware moat if your software, your architecture, and your algorithmic routing are efficient enough.
It reminds me of the philosopher Bertrand Russell. He had this concept that value is speed. In the physical world, moving atoms is incredibly expensive and slow. Mining copper, smelting steel, shipping physical servers across the ocean. But moving bits, moving information is cheap and fast.
Yep.
DeepSeek basically proved that the true economic value lies in having the fastest, most efficient semantic retrieval per unit of physical energy. You don't need to own the most expensive, power-hungry hardware if your algorithm can retrieve the exact same information faster and with a fraction of the joule output.
Which brings us to the great paradox of our current technological moment. We just spent all this time establishing that thanks to quantization, caching, MoE, and LLM-flation, tokens are getting cheaper and cheaper at a staggering rate. Therefore, you would intuitively assume that corporate IT budgets would be incredibly safe, perhaps even shrinking.
But they absolutely aren't. This loops us right back to the Jevons paradox we unpacked earlier. Companies are adopting so much of this cheap capability, integrating it into so many mundane processes that the utility billing is literally breaking Silicon Valley. We are witnessing the brutal reality of token shock.
We really are. We are seeing massive, financially sophisticated companies hit a brick wall. Uber, for example. Right. The source documents reveal that Uber exhausted its entire full-year 2026 AI budget by April.
By April, 4 months into the year. And we aren't talking about a small startup running out of AWS credits. This is Uber, a company with a total research and development spend of $3.4 billion. And they blew through their AI allocation in a single fiscal quarter.
And it wasn't just Uber. Microsoft, the company fundamentally powering a massive chunk of the global AI infrastructure, had to aggressively pull back Claude code licenses from its own internal engineers by mid-May, simply to save money on API calls to Anthropic.
Wow. If Microsoft is pulling back, you know it's serious.
This is happening because of a fundamental structural mismatch in how enterprise software has traditionally been budgeted versus how AI actually functions.
Let's explore that mismatch. Because for the last 15 years, the tech industry has been dominated by SaaS, software as a service, and SaaS trained every CFO and procurement department to expect a flat, predictable monthly fee. You pay $50 a seat per month for CRM software, and it doesn't matter if your sales team logs in once a month or uses it for 14 hours a day. The cost is fixed.
That predictable CapEx and fixed OpEx model is the absolute bedrock of corporate finance. Enterprise finance teams are completely built around predictable SaaS seats. But AI doesn't run on seat licenses. As we established with the physics discussion, it runs on utility billing.
Right.
It is exactly like a municipal water meter on a house. Every drop of water, every single token generated, costs a fraction of a cent. Because tech executives rush to push massive AI adoption mandates down to their teams without establishing proper governance.
Meaning they didn't implement hard token caps per employee.
Right, and they had no framework for measuring the actual return on investment of a query. So the massive financial exposure was entirely hidden.
It's completely invisible until the end of the month when the invoice arrives. Hence, the anonymous CFO opening an email and seeing a $500 million bill.
And this financial bleed is heavily exacerbated by the fact that tokens measure raw computational volume, not successful outcomes. In a traditional SaaS model, the software just sits there waiting for human input. In the AI model, the software acts on its own. If an engineer writes a terrible, ambiguous prompt, an AI agent might get confused, encounter a logic loop, and try to regenerate the answer endlessly, burning compute the entire time.
This reminds me of the AI haggling bots example we've seen in the news. An e-commerce company decides they want to use AI to offer dynamic pricing, so they set up a bot to negotiate with customers.
Classic use case.
But then a clever customer uses their own AI bot to negotiate on their behalf. You end up with two AI bots talking to each other infinitely, negotiating over a single cent difference in price for 3 days straight. The human customer and the human vendor are completely oblivious, but the enterprise is paying a utility cost for every single word generated in that multi-day robotic debate.
It is pure financial drain with zero corresponding business value. Consequently, the major platform providers, companies like GitHub, Adobe, and Salesforce, are scrambling right now. They are desperately trying to pivot away from raw token billing towards something they are calling outcome-based pricing.
They have to, right?
They realize the current utility model is financially unsustainable for their clients. And if CFOs keep getting $500 million bills, the enterprise adoption of AI will freeze completely.
But hold on, let me play devil's advocate here and push back on the panic a little bit. If we look at Uber again, yes, they blew their budget. But Uber's CEO, Dara Khosrowshahi, stated on a recent earnings call that autonomous AI agents are currently writing roughly 10% of their internally committed code.
Yes, that's a significant metric.
If an AI agent is actually doing the equivalent work of a salaried senior software engineer, someone making, say, $300,000 a year in San Francisco, isn't blowing a massive token budget still significantly cheaper than standard human payroll?
The raw math on paper suggests you're right. Substituting compute for human labor is the ultimate goal here. But we have to consider the trajectory of this consumption and look at the recent warning from NVIDIA's CEO, Jensen Huang.
What did he say?
He stated that we are rapidly approaching a reality where human engineers will likely need a $250,000 annual token budget running right alongside their standard salary. The human isn't replaced. The human becomes a manager of a massive compute budget.
Wow.
The math starts to completely break down when these autonomous agents start engaging in a behavior called token maxing without strict human supervision.
Token maxing, that sounds like a terrifying term for a CFO to hear, just churning through computation at maximum speed.
It is. Imagine a human engineer assigns a complex software bug to an autonomous AI agent on a Friday afternoon and logs off for the weekend. The agent starts executing steps. It plans, it writes code, it tests the code, it fails, it verifies the error, it self-corrects, and it tries again. It goes down an algorithmic rabbit hole. Because it operates at machine speed and doesn't sleep, it can execute thousands upon thousands of these trial and error loops. It can literally burn through tens of thousands of dollars of compute over a single weekend trying to fix a minor bug, purely because it lacks the human intuition to say, you know what, this approach isn't working, I should stop and try something else.
And that unsupervised token maxing is about to shift into an entirely new gear because we're officially crossing the threshold into the agentic era. We aren't just talking about chat boxes anymore. The widespread rollout of autonomous 247 AI agents that run persistently in the background is going to change the consumption landscape entirely.
The sheer scale of what is being announced by the major platforms is genuinely difficult to wrap your head around. Let's look at Google. At Google I/O 2026, CEO Sundar Pichai casually announced that Google is now processing 3.2 quadrillion tokens every single month across their ecosystem.
3.2 quadrillion. A quadrillion is a million billions. It's a number so large it practically loses all human meaning.
And that volume is going to spike because they just launched Gemini Spark. This isn't a search engine you visit. It is a 247 personal agent that runs continuously in the background of your digital life. It reads your texts, monitors your screen, pre-drafts replies, and organizes your files constantly.
Sounds exhausting, honestly.
On top of that, they introduced a framework called Anti-Gravity 2.0, which is designed to orchestrate multiple different AI agents working together simultaneously on a user's behalf.
So it's not just one bot, it's a hive mind of bots working for you around the clock. And if you look globally, specifically at China, the numbers are just as wild, if not more so. China's total national token usage recently surged to an estimated 140 trillion tokens daily. Just one single model, ByteDance's Dubao model, is consuming 120 trillion tokens a day all by itself.
What's crucial to analyze there is the specific nature of what is driving that massive consumption. It isn't just people asking text-based questions. It is driven heavily by AI-generated video and multimodal content. Dubao is deeply integrated into social media ecosystems.
Right.
Generating text is relatively cheap, but generating a high-definition video frame by frame, where every single pixel across time has to be mathematically inferred by the model, is incredibly token-heavy. A single 10-second AI-generated video can consume tens of millions of tokens in a matter of minutes.
So this leads to the ultimate question we promised to answer at the top of the show. How far can this physically go? If we are scaling up 247 background agents for billions of people, and everyone is generating millions of hyper-realistic videos on demand, we must eventually hit a wall. What is the absolute physical ceiling of human inquiry?
This is where the physics and the economics finally collide. We reviewed a fascinating ArcSIF paper that attempted to calculate humanity's absolute physical limit for computation based on projected energy availability.
Okay, what did they find?
The researchers looked at the projected 2028 United States energy grid allocation specifically earmarked for AI infrastructure. That estimate is roughly 326 terawatt-hours of electricity.
326 terawatt hours. That is a massive chunk of national power.
Yes. And if you assume maximum theoretical hardware utilization, taking into account cooling overhead and memory latency, that 326 terawatt-hours can support a maximum generation of 6.5 times 10 to the 17th tokens in a single year. That is the hard cap. The power grid simply cannot support more than that without causing rolling blackouts for regular citizens.
Okay, let me break that massive abstract number down into terms that actually mean something to a human being living their daily life. If you take that absolute maximum number of tokens, 6.5 times 10 to the 17th, and you divide it equally by the global population of roughly 8 billion people, you get an allowance. You get about 225,000 tokens per person per day.
And if we assume that a substantive complex query, a meaningful interaction with an AI agent that requires deep reasoning and a detailed output, consumes about 100 tokens, that simple division leaves us with an ultimate physical question budget.
2,200 questions. That is it. That is our daily allowance as a species. We have a question budget of 2,200 questions per person per day.
That is the physical ceiling of what the 2028 infrastructure can optimally support before we literally run out of electricity.
Thinking about having an allowance of 2,200 perfect, highly intelligent answers delivered to my pocket every single day brings to mind the famous economist John Maynard Keynes. Back in 1930, during the depths of the Great Depression, Keynes wrote a remarkably optimistic essay called Economic Possibilities for Our Grandchildren.
Oh, I know that one.
He predicted that eventually, through technological advancement and compound interest, humanity would actually solve the economic problem. He thought we would master production to the point where our greatest challenge wouldn't be starvation or scarcity, but a crisis of leisure.
Yes, that is the essay where he made his famous, though wildly inaccurate prediction of the 15-hour workweek. He genuinely worried that ordinary people wouldn't know what to do with a life devoid of grueling labor.
Exactly. And obviously, looking at the modern world, we haven't achieved physical leisure for everyone. People are working harder than ever. But looking at this 2,200 question budget, it feels like we have accidentally achieved cognitive leisure. We have 2,200 highly intelligent, automated, perfectly reasoned answers available to us every morning when we wake up.
That's a beautiful way to frame it.
Our core problem as a species isn't a lack of information or an inability to get answers anymore. Our crisis is figuring out what is actually worth asking.
That is a profoundly insightful way to look at the current paradigm. AI is a magnificent tool, but we must understand what it actually does. AI beautifully automates entropy reduction. It takes a massive, chaotic sea of unstructured data, processes the patterns, and gives you the most statistically probable answer. It organizes the chaos.
Right.
But it does not, and fundamentally cannot, supply agency. It does not supply directional coherence.
I like that. It can drive the car incredibly fast, and it can navigate the traffic perfectly, but it has no idea where we should actually go. It needs a human to input the destination.
Precisely. Under conditions of deep structural uncertainty, when the future doesn't look like the past, when we are facing novel, unprecedented societal or business challenges, optimizing your prompt doesn't matter if you are walking down the wrong path entirely.
Yeah.
Having an AI that can generate 2,200 flawless answers a day is totally useless if you're asking the wrong questions. The bottleneck for human progress is no longer computation. It is no longer information retrieval. The ultimate bottleneck, the scarcest resource left in the token economy, is human judgment.
What a phenomenal journey we have taken you on today. We started with the sheer comical absurdity of corporate consulting firms handing out physical black plaques to celebrate burning billions of tokens. We unpacked the deep, inescapable thermodynamics of computation, looking at Landauer's limit and why erasing a digital bit literally warms up the universe.
It's been quite a ride.
We looked at how models like DeepSeek shattered the global pricing market by ruthlessly optimizing the physical cost of a token through a mixture of experts and quantization. And we explored how this new 247 agentic era is completely blowing up Silicon Valley corporate budgets, ultimately leaving humanity with a finite, physical, daily question budget of 2,200 questions.
Before we sign off today, I do want to leave a listener with one final, deeply complex economic concept to mull over as they watch this industry evolve. It relates to a theory known as Arrow's impossibility result for information pricing.
Arrow's impossibility result. Okay.
Kenneth Arrow was a Nobel Prize-winning economist who pointed out a fundamental paradox in the economics of information. Information is uniquely non-rivalrous and non-excludable. But the core paradox of trying to sell an idea is this. As a buyer, you cannot possibly know the true value of an AI's answer until you have already received it and evaluated it.
Okay, yeah.
But the moment you have received it, you already possess the knowledge, so you have absolutely no incentive to pay for it.
Oh, wow. Think about that. If someone comes up to you and says, hey, I have $1 million idea, give me $50 and I'll tell you, you won't give them the $50 because the idea might be terrible. But if they tell you the idea to prove it's good, you now have the idea for free.
Exactly. It is a fundamental market failure for the pricing of pure information. So, as the entire enterprise tech industry scrambles to move away from billing for raw physical tokens and desperately tries to pivot toward charging for outcomes or business value to avoid those $500 million token shock bills.
Yeah.
This raises an incredibly important unsolved question. How will the market ever efficiently and fairly price an original artificially generated idea?
That is an absolutely fascinating paradox to think about as these massive corporate billing models inevitably shift over the next year. If you found this episode valuable, please like, subscribe, and share it with someone who desperately needs to check their corporate token burn rate before the end of the month. See you next time.